So here we're looking at section 4.5 from chapter 4. And so we're looking at solving quadratics. We talked about this last time, 4.4. But last time we talked about graphing to solve, looking for those x-intercepts, those solutions that when we plug in an x value, we get an answer of 0 in our equations. And so we also solve by square rooting. That's when b equals 0. Okay, now we're going to solve by factoring. So factoring is something we did before in chapter 3. And like I've practiced before, best thing I found is CAB, because we're taking our ax squared equation plus bx plus c, and here we have an equation. So before, when we're graphing, it was set equal to y, and then when we're either solving by square root or we're solving by graphing, that y turned to 0. And so now in section 5, what we'll see is sometimes that will be a 0, and then sometimes that might be a different some number. So what we want to do first is we want to get this number, if it's set equal to anything but 0, we want to get that to 0. So sometimes we'll have to subtract something or add something to both sides, depending on what that number is here. And then we'll get a 0 here. Okay? And then what we're going to do is we're going to factor, and this is where this 0 property comes in. So remember our factors. Whenever we factor a quadratic function or quadratic expression from chapter 3, it looks something like this, where we have two sets of binomials, right? Well, what the 0 property says, which you'll probably forget, but when we multiply two things, like here's one factor and here's another factor, and we're multiplying them, and the answer is 0, that means that only this thing can be 0, or this one can be 0, or both of them. So when I multiply two things, that's what this top thing says. When I multiply two things, one thing A and another thing B, and the answer is 0, so when I'm multiplying these, then either A is 0 or B is 0. Because I can't multiply two things, say like 3 and 5, and get 0, right? I can't multiply negative 4 and positive 4. Can't multiply those and get 0, right? The only two things I can multiply, one of them has to be 0 in order to get 0. Or they both have to be 0 to get 0. That's what the 0 property says, is when I multiply two things and the answer is 0, well, one of those things or both of those things are 0. So when we factor like this, and I get one factor times another factor, and the answer is 0, then I can set one of those factors to 0 and the other factor to 0, and then I can solve for x. Subtract 3 on both sides, so I get negative 3. Subtract 2 on both sides, I get negative 2. So those are my solutions, or my roots, or what we call zeros, because our y value is 0. So what we'll do in this section is we'll factor. We'll use CAB, right? Because CAB helps us find these two binomials, something like that, two sets of parentheses, and we'll just set each of those parentheses equal to 0. And then if you did the worksheet we did maybe last week or a couple days ago, whenever you watch this video, we practiced factoring, and sometimes we had to divide by our a. So if our a was like 4, we would divide these by 4, right? And I said, go ahead and leave these as fractions, right? Go ahead and just leave those as fractions, because you'll notice that just like this problem, my two factors are x plus 3 and x minus, or x plus 2 and x plus 3, and my answers are the opposites of those. So then when we leave us as fractions, we can just take the opposite of those fractions, and those would be our answers. Okay, so that's what we're going to do in this section. So there's a lot of problems in this, but we can move through them pretty quick. If I move too fast, you can slow it down so that I can talk slower. Or you can pause it anytime and practice the problems yourself. So I'd encourage you to do that, to try these problems, because not just watching it, you're going to get the information, but practicing as well. So make sure as you work through these, I'll work through one, you do the practice problems, right? You do the got it's. Okay, so these first ones are pretty easy. Because I'm multiplying these two binomials, I'm going to use the 0 product property and say that I can set just each one of them to 0 and solve for the variable. So this one I need to add 2 to both sides. So t is equal to 2. This one I need to do two things. I need to subtract 1 first, right? I usually do PEMDAS backwards, but as long as I do something on both sides, it's fine. Divide by 4 to get t by itself, because I want to do the opposite of multiplying by 4. I want to divide by 4, so I get 1/4. So those are my two answers, and they're both the answers, right? Okay, so that's how you do this. These type. Set each factor equal to 0 and solve for the variable. Okay, so you can go ahead and try on this. Got it? You can do this one. You can pause it and go ahead. I'll move on. Now solve by factoring. Here's where we're going to label our A, right? It's 1, our B, and our C. So here the only thing that's different, we'll get to on some different problems, is we're looking to make sure it equals 0. If it doesn't equal 0, then I need to subtract this number, add this number to both sides, which usually changes that C value. Okay, and there'll probably be some problems like that on here. So once I have my A, B, and C, then I just multiply C times A, so that'd be 15, and my B is 8. So because this is positive, then I know I'm going to be adding two numbers to get to 8. So I say what times what is 15, but if those numbers add to equal 8, well, that's 5 and 3. 3. And then I go ahead and divide by my A. My A is 1, so that's really not going to change these things. And then I write my two binomials, right? Because what times what gets me x squared? That's x times x. And then what times what gets me 15? That's 5 and 3. And then 5 plus 3 is the 8, right? So that's where these came from. 5 and 3, and it's a positive 5 and a positive 3. Now the only difference here between this solving by factoring and just factoring is now, because this is set equal to 0 and we're multiplying these two binomials, we can use that zero product property and set them each equal to 0, which is in essence just taking the opposites. That's why when we factor, we just want to leave them in terms of fractions, so then we can just take the opposites of those fractions. Because here, to get x by itself, as soon as I expand that, I subtract 5, which is the opposite, and I get x equals negative 5, which is the opposite of positive 5. Subtract 3, which is the opposite of adding 3. So I get negative 3, which is the opposite of positive 3 here. So those are my two answers, which we can see are the opposites of these. So these get pretty easy, especially when your A equals 1. You can just ask yourself, what is the opposite what times what is 14? But because that's a negative, you have to say what subtracts to 5. So what times what is 14 but subtracts to 5? Well, that's 7 and 2. And then you can go on from there. So you can cap this one. You can pause it because I'm already answering it for you. So might as well pause it. And I'll just do it real quick. Because I'm just showing you kind of easier way, especially when A equals 1. So because this is negative, I'm now going to subtract. And whatever the sign of B is, that's the sign of the bigger number. So must be a negative 7 and positive 2. And then I always that's it. All I have to do is take the opposite of those. So my M equals positive 7 and M equals negative 2. So those are my two answers for this. Got it. So that's a faster way to do it, especially when A equals 1. Okay, so writing in standard form first. So this is when we're not equal to 0, so we got to move it over. And I can't take it away from 21 because 21 has an x. I can't take it away from 18 or 4 because it has an x squared. So I just add it to the list, 21x, and there's my c. So now that it equals 0, now I can find my a, b, and c. And I always try to see if there's a common factor that I can factor out. Here, I can't, right? So then I go ahead to multiply my c times my a. So 4 times 18 is close to 4 times 20, which is 80. And then so 72. But you can do it on a calculator. And I'm trying to get to negative 21. So because this is positive, I'm going to be adding to 21. Okay. And since I'm adding and I'm trying to get to a negative, they're both just going to be negative. So what times what is 72 but adds to 21? And then since they're both negative, that will give me a negative 21, which I need. So 9 times 8 is 72, but it doesn't add up to 21, right? So we can play around with it. Look at our factor sheet maybe, if we have one. But I know 7 and 8 are, so I can kind of break this down and then mix up these numbers, right? I can put 3, 3, and 2, so that's 18 and 4. Is that 18 and 4 would be 22. Oh, is that a 2? Yeah, that's a 2. Well, it can be 3, 3, and 4, so that's 9 and 4. That's 36, so too much. How about 2 times 4 is 8. 8 times 3 is 24. 24 and 3. And let's just make sure we check here where I messed up. So we have 24 and we have 3. And I messed up here because this is a negative 18, so that should be negative, right? So I'm actually, because this is negative, I'm going to be subtracting. Sorry about that. And if I subtract these two, 24 and 3, 24 minus 3, I get 21. But I need a negative 21, so since I have to switch this sign, then I switch these two signs. That's negative and that's positive. Now I can divide by my a, which is 4. And so like I've said on other videos, normally we reduce these, right, and move over that c. Well, here, all I have to do is just take the opposites. So instead of negative 24 over 4, I'm going to take my x is going to be positive. X is going to equal positive 24, 4, which we do reduce to 6. So eventually we'll still reduce. And the 3/4 doesn't reduce, so x equals negative 3/4. We can leave it just like that. So there's our two answers. So it doesn't have to be as long. So you can go ahead and try this one. Move that over. It's positive. And this time our a is 1, so it's a lot easier too. Okay, here's a word problem, but are we going to do the same thing? Yeah, we are, because we have an area. An area of a rectangle is just length times width. But here we have a little bit something different, because here we're taking away an x, taking away an x. So really from this, let's say length, we're taking this x away and we're taking this x away. So when we have 11 inches here, for the whole frame, we're actually going to be adding a distance of x and adding a different distance of x. So that's really 11 plus 2x. And then my width is 17 inches for the picture, and then to add the frame is another x and another x, so that'd be 2x. So my width would be 2x plus 17. And we know that our area equals 315. So we want to know what these dimensions are from the outer frame. Okay, so what's the outer frame dimensions? So what we have to do kind of first here, which kind of stinks a little bit, is we're going to have to multiply this out. So we get 4x squared plus 34x plus 22x, and then 17 times 11, so I'm going to have to pause that and figure out what that is. So that's 187. So plus 187. So right now that equals 315, but in order to do what we have been doing, don't we got to set that equal to 0? So I got to take 4x squared plus 56x plus 187 equals 315, and I got to subtract that 315 because I need that to equal 0. So we can go ahead and subtract that, so that means we're going to get a negative, right? And 15, 13 is 28, so we get a negative 28, positive 56x, and 4x squared. Now it equals 0, so now we can take and we can factor this. But what we want to do here is probably factor out a 4, because they're all divisible by 4. And that will just make it easier on us, because then our a is going to be 1. So we'll minus that, and actually, if I didn't do my math right, that's actually negative 128. And so then we set it equals 0. We can still divide by 4, which gets us our to 1, and that's 14x. So we're factoring out a 4. So the 4 goes on the outside, and that'd be 32. And then we can get rid of that 4 by dividing by 4, because this is multiplying, so we can divide both sides by 4. So this is kind of a technicality thing that we have to do, because we have to keep our statement true. That's why I had to write the 4 in there and divide by 4. But you could take this original one and you could cab it if you wanted to. But it's easier if you factor out 4. So then because my a is 1, this is really easier. I just say what times what is 32, and because that's negative, I'm going to subtract to 14. So what times what is 32 but subtracts to 14? That's 16 and 2. And whatever the sign of b is, that's the sign of the bigger number. And because that's negative, one of them has to be negative, so that means that one has to be negative. Because whenever one's positive and one's negative, the larger number will always get the sign of b. Okay, now I divide by my a, which is 1, so that's what's great about factoring a 4. My a is 1, so then all I have to do is just take the opposites, negative 16 and a positive 2. Now, because the context of the scenario, this one doesn't matter because we're talking about length, right? So that means the picture frame, what we're adding on this distance to the frame itself, 2 here, 2 up here, 2 to the side, and 2 below. So normally this was 17, and so we're going to add 2 and add 2 more, so that's 21. By, this was 11, and we added 2 more here and 2 more here, so that's 15. So it's a 21 by 15 frame that we want. Okay, same scenario, except for now, instead of setting equal to 315, we're going to set it equal to 391. And the only thing we don't even have to change that equation that I came up with. It's those two sets of parentheses. We don't even have to change. So when I FOILed this out and got the 187 and 56x, you don't even have to change that, right? You just have to change that 315 number, okay? So go ahead and do that, and then factor it. Maybe you can factor a number out, which might make it easier. So then maybe your a is 1. Okay, so try that. Okay, a couple more problems here. Using factored form to graph a quadratic function. So how we do this is we're going to find the zeros, right? What makes our y0 or x-intercepts or solutions. So what we're going to do here is we're going to set this equal to 0. Okay, and we're going to factor it. So instead of f of x, or instead of y, we're going to have 0 there. And so then we can take our a, our b, and our c. Take c times a, which is 5, which is nice because our a is 1. And our b is 6. And we say what times what is 5. Because that's positive, we're going to add 6. So that's 5 and 1. Here we don't need to divide by our a because our a is 1. So now we can just take the opposites. So that, or we can write factored form, which is x plus 5 and x minus 5. Or x plus 1, sorry. And now the answers would be x equals negative 5, the opposites, and x equals negative 1. So what that means is when I'm graphing, because it's kind of asking us to graph, these would technically be the zeros. Those are our x-intercepts. So at negative 1, we have a point, and at 1, 2, 3, 4, 5, at negative 5, we also have a point. So those are our answers. So when they ask for zeros, they're asking for our x-intercepts, those same things. They're asking for the solutions. They're asking for the roots. Those are all the same things. And then we can go ahead and use that information to plot those on the graph. And then all we have to do is find the middle between those, right? And so that's why we always divide by 2 times a, because we're finding the middle, so that's part of dividing by 2. And so we could find the opposite of b, which is negative 6, and divide by 2 times a. Our a is 1, so we get negative 3. So at negative 3 is our axis symmetry, so our vertex is somewhere along here. I can plug in negative 3 in for my x's and figure out what that value is. So once I have my x-intercepts, I can go ahead and find that vertex, plot my graph, and let's see, negative 4. So it's like this. Because I just plugged in negative 3, which is 9, negative 18, that's negative 9, plus 5 is a negative 4. Okay, so you can go ahead and do this one. Go ahead and that looks like the exact same thing. Oh, what is the graph of the function? Oh, look at that, I just did that. So go backwards a couple seconds, and you can get that answer for B. Okay, so here you go. What are the zeros? So that's doing the same thing we're doing. You can cab it. Because this is negative, we're going to subtract a 4. Because that's negative, the bigger number is going to be negative, the smaller number is going to be positive. Okay. Alright, that's it. Another video for you. All done.